And on 166, they have this box in the shaded part again. First thing I'm going to get you to do with that box is I'm going to get you to rewrite this by moving the k over to the other side. Because almost everything we're going to do, we're going to get y by itself. And then this is on page 166. And getting that y by itself will mean that you can see what's inside the function and what's outside of the function. Okay? And then we're going to look at the example above because it adds a little bit more complexities. Okay? This time, we get an equation of a graph that we don't know, something new. The red graph is y equals negative x to the 4. And we want to graph in the blue that they have there, and I'm going to rewrite the blue equation by moving that 4 over. Negative x minus 2 to the 4 plus 4. Now, if our original function was a negative x to the 4, and now we're looking at the new function, what we're trying to determine is what's changed. Okay? There's a negative in front of the red graph. There's a negative in front of the blue graph. That doesn't change, so that's not affecting anything in the graph right now. But instead of just having x to the 4, we now have x minus 2 to the 4. And so that's inside the function. That's going to move it 2 to the right. And we now have a plus 4 after or outside of the function. That's going to move it 4 up. Can you see that this point here has been moved 2 over and 4 up to get to that point there? Okay? But this one could cause us some problems later on because they gave us a negative in the original. We have to say what was given to us originally and what's changed. Okay? In parabolas, what happens when you have a negative outside of a parabola? It flips it down, right? So what did this negative do to a regular x to the 4 graph? A regular x to the 4 graph would have been up here, and it got flipped down. So we're going to learn about those kind of things later on. Because we're not only going to be moving things left, right, up, and down in this unit. We're going to be flipping things this way, flipping things that way, stretching, compressing, and then doing them all together. So some of these things, when they're given to you, you have to say, well, what's changed? What was originally given to me? What do I have now? And then what are the transformations that would do that? So when we get to example 2 here, a fancy W graph, which they call J of x. They should have called it W of x, but it's whatever. So we've got a new graph, J of x. It says, sketch the image graph after a translation of 4 units left and 5 units down. Well, I can do that because I could take this point, and this point. Those seem to be key points on the W. I could move that point, the first one, I could go 4 to the left, 1, 2, 3, 4, 5 down, 1, 2, 3, 4, 5, draw the point. Next one, 4 to the left, 1, 2, 3, 4, 5 down, draw the point. This one, 4 to the left, and 5 down. And then draw the same shape, put arrowheads on the end. Okay, now I'm going to read my question, start it again. Here's the graph of J of x. Sketch the graph. Translation 4 units left and 5 units down. Good. Double check. I did that. Next one, write the equation of the image graph in terms of the function j. So we're getting this language again. So it's an equation. I want an equation for my blue one, y equals, in terms of j. So my function j has to be here. If I'm going 4 to the left, does it make sense that inside I would have x plus 4? And if I moved it 5 down, does it make sense that outside I would have minus 5? So here in function notation, it's been moved 4 to the left and 5 down. Read my sentences again. First sentence good, second sentence good, third sentence now good. State the domain and range of each function. So my red one, domain. Well, there would be arrowheads here, meaning that it's going up forever and getting wider forever. So my domain in set notation would be everything, XER. My range in set notation, y is bigger than or equal to 0. You remember how to do domain in interval notation? How would I do everything? Negative infinity to infinity. How would I do every y is greater than 0? 0 to infinity. That's interval notation. And then for my blue graph, the domain, well, it was everything to begin with, and then I moved it to the left. It's still going to be everything. But my range wasn't everything to begin with. It was just bigger than or equal to 0. And now I've moved it down 5. It's going to be bigger than or equal to negative 5. Or negative infinity to infinity, or negative 5 to infinity. So we can now try 8, 9, and 10.